States of matter, gases and liquids. Question number 1. Which among the following options are correct graphical representation of Boyle's law? What is the Boyle's law? In Boyle's law, pressure is inversely proportional to volume, and when you remove this proportionality constant, you have to put constant. It is P equal to K into 1 by V. So where constant is temperature and number of moles are constant. Now it is in the form of Y equal to mx. Now it is in the form of Y equal to mx. When you plot the graph Y versus x, in the place of Y we have the P, in the place of x we have the 1 by V, and the Y equal to mx graph represents the line passing through a origin, and this slope indicates the constant. So what is the constant terms here? The constant term is temperature. Okay, if slope value increases, the temperature also increases. So slope represents the constant term. So here which one is constant? Temperature is constant. So slope increases, the temperature value increases. Means here among these 4 graphs, so which one is matching here? Option A is matching. So the slope T3 graph is more than T2, so which is more than T1. So the T3 has more slope than T2 and T1. Means the T3 is greater than T2, which is greater than T1. So your option A is matching. The next question. Intermolecular forces are forces of attraction and repulsion between interacting particles that will include dipole-dipole forces, dipole-induced forces, hydrogen bonding, covalent bonding, dispersion forces, and choose the most appropriate answers from the option given below. Okay, among these all types of forces, and all these forces are intermolecular forces, and these are very weak forces, and it may be repulsive forces or attractive forces, except to covalent bonding. Remaining all forces are intermolecular forces. Okay, so your answer, which one is matching here? Is A, B, C, E. So your option B is matching. Question number 3. The correct van der Waals equation for 1 mole of real gas is. So already you know that. What is the real gas equation? The real gas equation is P plus AN square by V square into V minus NV equal to nRT. Okay, so just you here van der Waals equation for 1 mole of an ideal gas. In the place of N, just you put the 1 mole, N equal to 1 mole. Okay, then equation becomes like this: P plus A by V square into V minus B equal to RT. So your option, which one is matching option? Option yes, A is matching. Question number 4. The correct option in which the density of argon is highest. Okay, so you just see the formula, just you check the 4 options, in which option the density value is more. So what is the formula of density? From ideal gas equation we know that PV equal to nRT. So P equal to nRT by V. So this N we can write as weight by molecular weight into RT by V, then weight by volume into RT by M. So this will give density dRT by molecular weight. Okay, from this we can calculate the density of argon gas. So density of argon gas equal to pressure into molecular weight, the universal gas constant, R into temperature. Okay, so now this R value is constant and molecular weight of argon also constant. Then density depends on only 2 things, and pressure and temperature. Okay, so STP means standard temperature pressure condition, means at 0 degrees Celsius 1 atmospheric pressure. Okay, in all conditions you check the density of the argon gas, in which condition it is showing more. Let us check the option A here, right? So density of STP, at STP condition you check the density of the argon gas. So density equal to here molecular weight and R value is constant. The density depends on pressure and temperature. Here pressure is 1 atmosphere, 0 degrees Celsius you convert into Kelvin, it will be equal to 273, 0 plus 273. This is 1 by 273. Next option B. In option B you check the density of argon gas at the given condition. Here temperature is given is 0 degrees Celsius, that is 273. Pressure is 2 atmosphere. So the density is 2 by 273. Next you check the option C now. Okay, option C, you check the option C. So in option C they given that temperature is 0 degrees Celsius and pressure is 4 atmosphere. So density equal to pressure by temperature. So pressure is 4 atmospheric pressure and temperature is 0 degrees Celsius. 0 degrees Celsius means 273 Kelvin. And in option D check the density value. Okay, so density equal to pressure by temperature. So pressure given here 4 atmosphere and temperature given 273 degrees Celsius and convert into Kelvin. When you convert into Kelvin, just you add the 273. 273 plus 273 is 546. So this we can write as 2 by 273. Now you see in all options the denominator value is same. Then you check the numerator value. Okay, so here the numerator value is 1, here it is 2, and here it is 4, and here it is 2. And all denominators values are same. Then you check the numerator. The numerator here in option C it is 4. Means the density at which condition it is more? 0 degrees Celsius, 4 atmosphere pressure. The density of argon gas is more compared to the remaining options. Okay, then move on to the next question. Which one is not correct mathematical equation for Dalton's law of partial pressure? So where P equal to total pressure of gaseous mixture. Okay, and you know that what is Dalton's law? Dalton's law equal to the total pressure of the gaseous system is equal to sum of partial pressure of all individual gases. Okay, according to we know that what is that PV equal to nRT. So from this we can write as P equal to nRT by V. So then we can write P1 is equal to N1 into RT by V, and P2 we can write as N2 into RT by V, and P3 we can write as N3 into RT by V. Okay, and the first option A correct, and for second option B also correct. P means here total pressure, and the third option C you check here. Partial pressure of individual gas is equal to mole fraction of that individual gas into total pressure. This is also correct, but the D option is not correct. Here partial pressure of individual gas given that mole fraction of individual gas into the partial pressure of individual gas in pure solvent or pure. Okay, when it is only individual, when you consider only individual gas, the partial pressure of the individual gas is equal to mole fraction into individual gas and pressure of that gas in its pure form. But this is not correct. So remaining all options are correct except D. Remaining all are correct. So here you have to choose that which one is not correct. Here option D is not correct. Okay, move on to the next question. So here we have a 10-liter flask. Okay, so what is the volume of the flask? Volume of the flask is 10 liter. Contains 64 grams of oxygen at 27 degrees Celsius. We need to find the pressure inside the flask in bar is. Okay, so you find the number of moles. Number of moles equal to weight by molecular weight. Here weight is 64. Molecular weight of oxygen is 32. 64 by 32 is how much here? 2. N value is 2. Volume they given, and R value also they given. How much it is? 0.0831 liter bar per Kelvin per mole. Okay, and temperature also they given. Temperature is how much here? 27 degrees Celsius. You change into Kelvin. This is, it may be equal to 300 Kelvin, and you find the pressure. Okay, so PVNRT, which formula you have to use here? Ideal gas equation you have to use, that is PV equal to nRT. Okay, from this formula, this P we can write as nRT by V. What is the N here? N value is 2, R value is 0.0831, and temperature value is 300 Kelvin, and the volume is 10 liters. So 0 cancel. So 60 into 0.0831, so which is equal to 49860, and after 4 digits you put the point. Okay, so it may be how much it is? 4.986 bar, and in the